Welcome to this video on my version of an etchasketch using an Arduino Uno and a 64 LED dot matrix. So part one of two videos is going to be lighting up a single LED. There's a schematic, and if I move the LEDs, you can see the negative cathode is common to all LEDs in a row. All the cathodes are connected in a row, and all the anodes, the positive LED terminals, are connected to each other in a column. I've made it so that the top row of LEDs is connected, the cathode, to pin 2, and the bottom row's cathode is connected to pin 9. So 2 to 9 are the rows. And then the left-hand column is connected to pin 10. Then there's pin 11, 12, 13, 14, 15, 16 and 17 is the anode of the right column, pin 17. We've got two 10k pots, and one of them is for the row that we're going to write low, and the column pot is for the columns that we're going to put 5 volts to. So the pots have 0 to 5 volts, and a voltage comes out that we do an analog to digital conversion with analog read. And that gives us a number to between 0 and 1023 that we chop up into 8 segments. Now this switch is a simple on-off binary switch to change between the display mode, where we're lighting one LED, and the full etch-a-sketch mode, and that's gone to pin 1. We digital read that. So rows need to be at 0 volts or logic 0 in order to be active, and columns need to be high in order to be active. And this shows the only way that the LEDs will light, when the rows are low and the columns are high. You can get common anode displays which work differently. So when the rows are high, nothing will happen, regardless of whether you put 5 volts or not on the LED. So bring the row low, and as you then put a column high, it lights those LEDs. And this just shows you how it works. Basically, have a quick play around with the logic levels to see how to activate certain LEDs. When the rows are high, it doesn't matter what you put on the columns because they won't light up. So to light one LED at a time in what I call positioning mode, this shows you the logic levels that need to be on each of the pins shown. So we do analog reads, and as the voltage changes and the analog integer changes, we can then set rows low and columns high to light up any of the LEDs. So an analog reads gives you an integer between 0 and 1023, and we've got 2 of these pots. We'll do analog reads on both. And for the rows, depending on what the analog read value is, we're going to set these different pins low to activate the rows. And here's a table that just shows you some of the ranges that we're going to use for our analog read and which row to enable. And the same for the column. Apart from obviously the column potentiometer, we're going to use that to write a logic 1 as in a high level for pins 10 to 17 to activate the columns. So let's get started with the code. Get rid of all the stuff that we don't need. So we need some integers. I've got an int called row pot, which is the potentiometer for the rows. That's pin 19, and the column pot is in pin 18, but you can change them if you want. Got an integer for the value of the row pot and for the column pot. And I've got 2 integers, one called row and one called col. And they're going to be the actual ones that we use to make a particular LED turn on. So what we're really after doing ultimately is digital write a row low and digital write a column high, which will give us one particular LED, delay a bit just to make sure the LEDs are bright enough, and then disable the row and disable the column, and it'll keep going through that loop forever. So to set up, what I'm going to do here is a for loop to set every one of the pins from pin 1 to 19 as an input. And that's only because I've got two inputs on their own, then I've got one input in pin 1, then two inputs on 18 and 19. But then I can immediately make the pins I want to be outputs. Pins 2 to 17 are then outputs. Even though we just made them inputs, it's the last thing that you do that matters. And that's a lot quicker than doing each individual pin mode. Now to initialize everything, when you turn the Arduino on, you want to make sure that your rows are high so that you don't get any dodgy LEDs lighting up. So this disables all of the rows by setting them high. We just do this once when we turn the thing on. And then we do the same for pins 10 to 17. We're going to initialize the columns as being low so that there's no current going through the LED. Then to get cracking with the analog reads, so we'll say the row potentiometer value is the analog read of row pot, and the col pot value is the analog read of the column pot. So it takes those voltages in, converts them to integers, and then below we're going to assign the analog read values to different rows and columns. And this is like an if statement, so depending on what the analog read voltage and integer is, we will do different things. So if the row pot value is at its smallest value, the row that we're going to make low is row 9. That's the bottom row. That's on pin 9. And then have I done that right? Is it going to be row 10, the next one? Have a think. So between 128 and 256, we're going to make the next row active. And what is the next row? The next row is pin 8. So we go through all the different values of analog read, and then we set a different row low to activate it depending on what the value is. So the next one's going to be from 256 to 384. Then it's going to be from 384 to less than 512. Then 512, we're adding 128 each time. We're dividing it up into 8 sections of analog read integer value. And then the last one, the top row in pin 2, we only need it to be greater than 896. We don't need to say from 896 to 1023. There's no point. Then we can copy that and do the same for the columns. Change all of the row words to col. And then change the pins that we're going to eventually write high. So we need to write the rows low and the columns high. So that's from pin 10, which is the left-hand column, all the way over to pin 17, which is the rightmost column. So a quick recap. We've got our pot pins, our pot values, some integers to write high and low. We've done the pin modes, and then we've initialized our outputs to be inactive. We've done an analog read of both pots, and then depending on what the analog read value is, we're going to set rows low and columns high. So now we can get rid of the commented out parts and make them active. So we're going to digital write the row pin low, digital write the column high. That'll light up a particular LED. Then we're going to delay for about 3 or 4 milliseconds just to make sure that the LED gets fully lit, otherwise it may look dim. So turn on one LED and then disable it again afterwards. And that's about it. So we copy our code, paste it into Tinkercad or Wokwi or whatever, and then we can play around with it. So here the row and column values are changing, so the integers row and col change. So this is the first part of the circuit done with all the code. And the next thing we're going to do is come up with a little bit more intricate code to make sure that we can actually draw things. So the sketch and etch, I don't want to get sued, is the next part. So thanks for watching.